Hello, in this video we'll talk about isomers. What are isomers? Isomers are some different compounds having the same molecular formula. Consider such a molecule. Here I have 4 carbon atoms, it is butane. I have 4 carbon atoms and 10 hydrogen atoms in total. With the same combination of atoms, it's also possible to have another structure. I can take this carbon atom from here and change its place with one of the hydrogens from the middle carbon. And I can do like this. Did I add any carbons? No. Or remove anything? No. So, this compound and the previous compound contain the same number of carbons, same number of hydrogens. They both contain 4 carbons and 10 hydrogens. But are they the same compounds? No. They have different physical and chemical properties. So, such compounds are called isomers of one another. Let's draw them on the whiteboard in here. So, my compound was C4H10. When you have 4 carbon atoms, what you can do is that you can put them all on the same line, like butane. Or, as we did, you can take one of the carbon atoms out and you can put it as a branch on the middle carbon atom. Now, as you know, every carbon atom is making 4 connections. This is making 1 connection, so it needs 3 more. Here it needs 2 more, 2 more, and 3 more. Now I'm writing, but for simplicity in the other examples I will not write them. Now let's have a look at another molecule. So let's have C5H12. The first compound that I can think of is something linear, pentane. Another compound that I can draw could be with 4 carbon atoms. What about the 5th one? It's going to be a branch. So let me ask you a question. Can I put my branching in here on the first carbon? No, because it's going to be the same as this one, right? Or can I put it in here on the last carbon? No, it's going to be the same thing again. What you can do is that you can put it on the second carbon atom in here. So it's going to be 2-methyl butane. Let's try some more. 4 carbon atoms. I'm putting this time my carbon branching in here. Is the new isomer? Actually not. As you see, this compound and that compound are the same. I just have rotated the molecule 180 degrees. Okay, so does it mean that we don't have any more isomers? Maybe I have something with 3. So if I have 3 carbon atoms on the main chain, I need to have 2 branches. As I said in here, you cannot have branching carbon branches on the first or on the last carbon atom. So I'll put both on the second carbon atom. Then it's gonna be 2,2-dimethylpropane. And finally, let's have a compound like this, C3H7Cl. This time I have a third element, chlorine. In such a case, I recommend you to think like this. So it's C3H7Cl. So this Cl came to the place of some hydrogen. So this compound originates from C3H8, right? So this compound and the general formula fits to the general formula of alkenes, NH10 plus 2. So all the bonds between the carbon atoms are single bonds. So I have 3 carbon atoms with all single bonds. Then I can put my chlorine in here. So this is going to be 1-chloropropane. But it is also possible to draw the same chain like this, 2-chloropropane. That's all for this video. Thank you for watching. See you on the next one.